Everything that I was teaching, I first had to learn, from features on Altium to the intricacies of designing electrical circuits, and those were really helpful for learning on the fly. Monash UAS is a student team that builds, designs and flies drone aircraft for humanitarian purposes.
There is a stigma around drone technology. There's a lot of uses for it, but not a lot of people know about the positive aspects of what it can be used for.
As part of that, we have a search and rescue mission that we've set up to try and showcase the usefulness of drones in this sort of scenario.
We have an isolated individual who's been bitten by a snake in the outback. This person might take a very long time to get a medical helicopter into place to pick them up, or we can use our search and rescue drone to deliver them antivenom.
That involves flying autonomously and detecting a patient in need on the ground, and then lowering them some medical supplies.
We have a very advanced algorithm which can actually look at the ground underneath and identify where potential patients may be. And then we can choose to deliver that via our payload delivery system straight to the patient who's in need, cutting hours out of their recovery journey.
It's such a tiny little space.
Do the thing where you do it like this, snip the legs, and then slow that. It should be okay.
Yep, we can try that.
There's a few considerations that go into a system like this.
You need a camera, you need artificial intelligence to detect people. It needs to be able to carry a payload. We know that we need an extra connector on the board in a particular place, which is going to reduce the amount of wiring in the plane. And we know that we can save money by custom designing our own circuit rather than buying something off the shelf. So there's so many different little components that come together, and that also integrates different fields of engineering to complete a mission.
Our team as a whole has very much been the backbone of our electrical system design. It just streamlines everything, makes everything a lot more efficient.
So previously the team has worked quite siloed. So avionics and aerostructures both independently design their own systems. Before co-designer, that sort of process would have been done using calipers and by hand drawing out where everything sits and measuring everything up. However, now by just simply importing the board into MCAD, we can see exactly where the connector sits on the board and where that board sits within the aircraft itself.
In that case, let's just measure the resistance of it on here. Now that I know which one it is, it should be that one just there. We'll need a multimeter.
Is it a voltage divider or something? Like, does it actually matter?
Having features like being able to comment and the version control allows us to work together and learn from each other in some ways on these projects while we're working on them. Especially considering the large team that we are working in. We have about 6 students working on this project at one time. They can grab those changes and continue working on their part of the project. As you can see, there's many revisions made to this one board and lots of different names, lots of different people working on this project.
In avionics, we see PCB design as a hugely valuable skill because it's something that's not really taught in university. And if you want to get that sort of experience with PCB design, you really have to go out of your way and seek those opportunities yourself.
I think it's fantastic that I've gotten to get all this hands-on experience through the team and through using Altium Designer. I would never have gotten these skills if I hadn't have joined the team. It's going to be very valuable, I think.